8.9, the second derivative test. Remember, in the first derivative test, um, can help us figure out whether a point is a maxima or a minima. We know that at both maxima and minima, remember maxima means highest, minima means lowest. At those points, the first derivative is 0. Those are critical points. The first derivative test tells us that if the first derivative goes from negative to positive, then we have a minima. And if we go from positive to negative, then we have a maxima. But is there another easier way of figuring out whether it's maxima or minima? And the answer is yes. On this graph, we have some maxima and some minima. Remember, the second derivative tells us concavity. So if it's like a U, then it's positive concavity. The second derivative is positive. If it's like a rainbow, then it's negative concavity. The second derivative is negative. Okay. Let's look at our maxima. There are 3 maxima points here. All of them look like a rainbow. So all of them have negative concavity. So all of them look like this. And at the 2 minima, it looks like a U is going down and then going up. So whenever there's a minima, you can see this. Whenever there's a minima, it is concave up because the graph looks like a U. So if it's concave up, the second derivative is positive, then we have a minima. And if it's concave down, the second derivative is negative, then we have a maxima. That's the second derivative test. If f of x has a local extrema, maximum or minimum at x equals c, then f of x has a f of x has a maximum at x equals c if the second derivative is negative, and f of x has a minimum at x equals c if the second derivative is positive. For example, the function f of x equals x cubed minus 5x squared plus 3x minus 4 has local extrema at x equals 1/3 and x equals 3. Identify whether there are maximum or minimum points. Alright, so let's take the derivative. We need a second derivative. So the first derivative will be 3x squared minus 10x plus 3. And in fact, if you solve this equation, 3x squared minus 10x plus 3 equals 0, you will find x equals 1/3 and x equals 3. So the second derivative would be 6x minus 10. Okay. So the second derivative at x equals 1/3 has to equal 6 times 1/3 minus 10, which is 2 minus 10, which is negative 8. Since this is negative, we have a maximum at this point. Okay? Again, second derivative is negative, we have a maximum. Next, let's test our second point. When the second derivative, when x equals 3, f prime prime of 3 is equal to 6 times 3 minus 10, 18 minus 10, which is positive 8. Well, since the second derivative at x equals 3 is positive, we have a minimum point. Okay, so x equals 3 minimum, x equals 1 over 3 maximum. Let's see if that's right. Let's go to Desmos. We will type in our function. it is x cubed minus 5x squared plus 3x minus 4. Let's see. And that's right. Desmos shows us that at x equals 1/3, we have a maxima, and at x equals 3, we have a minima. So that's the second derivative test. Second derivative negative, maximum. Second derivative positive, minimum.